Here I want to find the indefinite integral of 3x squared cosine x cubed dx. Here this is a complex function, it's hard to integrate, so I'm gonna check a few substitution applies to write that integral in a simple form. Then a few substitution applies, I'm gonna follow the 3 steps. So I'm gonna equal the u function to the inside function. Then the second step, after making the substitution, I'm gonna integrate. And then the third step, I'm gonna back substitute the function of u. So here, I'm looking into this function, and I want to see a term and the derivative of that term on the same function. Notice in here we can see a relationship between x cubed and 3x squared. When we take the derivative of x cubed, it's gonna be equal to 3x squared, which is found in the function. Therefore, x cubed gonna be our inside function. The first step, I'm gonna assign x cubed to u. And then du over dx with the derivative of u gonna be equal to 3x squared. Now I'm gonna move dx to the other side. Or what we can do, we can see du, and then every time we integrate x, it's gonna be equal to dx. This is a way easier. I'm gonna use that in the following examples. So for step number 2, I'm gonna integrate after I make the u substitution. So here what I did, I arranged the term. I brought 3x squared next to dx, and that from step 1 gonna be equal to du. And that's gonna be equal to cosine of u du. This is a way easier to integrate. We already know the antiderivative of cosine of u. That's gonna be equal to sine of u plus c. Now in the third step, I'm gonna back substitute the function of u. So here u gonna be equal to x cubed in the first step. Therefore, we will have sine of x cubed plus c, and that's the antiderivative. Now we can check our work. So I'm gonna assign the antiderivative to f of x, and then I'm gonna take the derivative of that function. Here I'm gonna use the chain rule. So it's gonna be first the derivative of the outside gonna be equal to cosine of x cubed, and then the derivative of the inside would gonna be 3x squared. And then the derivative of c, a constant, is just 0. Now I bring 3x squared to front of cosine, and we can see it's gonna be exactly the same as in the integrand. Now, find the integral of x cubed multiplied by the square root of x to the 4 plus 5 dx. So here first I'm gonna check if u substitution applies. I'm gonna look to this function. I'm gonna find a term and then try to find the derivative of that term on the same function. Notice in here, when I'm taking the derivative of x to the 4 plus 5, it's gonna be equal to the 4x cubed. Notice here x cubed, it's in the function. Therefore, u substitution applies, and the inside function gonna be equal to x to the 4 plus 5, which is gonna be equal to u on the first step. Now, the derivative of u gonna be equal to 4x cubed dx. Now in the second step, I'm gonna try to integrate after making this u substitution. First, I arranged the terms. I brought x cubed next to dx. Notice now, this term, x cubed dx, I'm gonna move 4 to the other side, so we only have this term. Now, we will have the integral of square root of u, and then x cubed dx gonna be equal to 1 over 4 du. Now I'm gonna move 1 over 4 to outside of the integral, and then I'm gonna write square root of u as u to the power of half. Gonna be equal to 1 over 4 u to 3 over 2 over 3 over 2, and then plus c. Now what I'm gonna do, I'm gonna simplify this term in here. 1 over 4 multiplied by 1 over 3 over 2. This is gonna be equal to 1 over 6. This is gonna be equal to 1 over 6, and then u 3 over 2 plus c. Now we are ready to move to step number 3, which is back substitute the function of u. Remember, from step number 1, u is gonna be equal to x to the 4 plus 5. And that's gonna be our antiderivative. Now for part 3, find the integral of e to the cosine of theta, sine of theta, d theta. Again, this is a complex function. We want to write it in a simple form to integrate it. So I'm going to check a few substitution applies. Notice in here, when I take the derivative of cosine of theta, it's going to be equal to minus sine of theta. And sine of theta is already a term in our function. Therefore, u substitution applies. And the inside function gonna be equal to cosine of theta in our first step. Du gonna be equal to minus sine of theta, and then d theta. Now notice here, we only have sine of theta, d theta. So what I'm gonna do, I'm gonna move minus sine to the other side by multiplying both sides by minus 1. Now second step is to integrate after we make the u substitution. This is just the integral in the top. Gonna be e to the u, and then sine of theta d theta is equal to minus du. I'm gonna pull the minus out of the integral, and we already know now the antiderivative of e to the u. You can notice this is a way simpler form to integrate. The antiderivative gonna be equal to minus e to the u plus c. Now we are ready to move to step number 3. I'm gonna back substitute the value of u from step number 1, which is cosine of theta. And that is our antiderivative. For 4, find the indefinite integral e to the t over 1 plus e to the t dt. This is a complex function which we cannot just integrate it right away. So I'm gonna check a few substitution applies in here. Notice here, when I integrate the bottom function, it's gonna be equal to e to the t, which is the top function. Therefore, u substitution applies, and the bottom function is the inside function. Therefore, the first step, u of t, gonna be equal to 1 plus e to the t. Then du gonna be equal to e to the t dt. Now in the second step, I'm gonna try to rewrite our integral. It's gonna be the integral of 1 over the bottom, and then e to the t dt. Now notice e to the t dt is actually just du. Then 1 plus e to the t is u from step number 1. Therefore, this is gonna be equal to the integral of 1 over u du. Notice this is a way simpler form. The antiderivative is just the natural log of the absolute value of u plus c. Step number 3 is back substitute the function of u from step number 1. Notice in here that the function 1 plus e to the t is always positive for positive values, negative value, and a 0 value. Therefore, it's just going to be the natural log of 1 plus e to the t plus c. We move the absolute values. Here, find the integral of tan of theta d theta. You may say this is an easy function, but it's not actually, since we didn't know how to take the integral of tan of theta. So, we want to write tan of theta. Tan of theta gonna be equal to sine of theta over cosine of theta. Therefore, the integral on the top gonna be equal to the integral of sine of theta over cosine of theta d theta. Again, we didn't know how to integrate this function, so now let's check if substitution applies in here. Notice in here, when I'm differentiating cosine of theta, which is the bottom function, it's gonna be equal to minus sine of theta. Note here, sine of theta is the top function. Therefore, substitution here applies, and the inside function gonna be equal to cosine of theta in our first step. Now, du gonna be equal to minus sine of theta d theta. Note in here we only have sine of theta d theta, so I'm gonna move the minus sign to the other side. Now for second step, I'm gonna integrate after making the substitution. I'm gonna arrange here, gonna be 1 over cosine of theta and then sine of theta d theta. Notice that sine of theta d theta is just equal to minus du, and cosine of theta is just u. So that's gonna be the integral of 1 over u and then minus du. Now I'm gonna pull the minus sign out of the integral and we're left with 1 over u du. Now we can take the integral of this function. It's just gonna be minus natural log of the absolute value of u plus c. Now we can back substitute the function of u from first step. It's gonna be cosine of x. Part 6. Find the integral of e to the x cosine x cubed e to the x sine of e to the x dx. You may notice this is a way complex function, but actually this problem can also be solved using substitution. Notice here when I take the derivative of cosine of e to the x, it's gonna be equal to minus sine of e to the x multiplied by e to the x using the chain rule. Notice here this term is actually given in our function. Therefore, substitution applies. Now the inside function gonna be equal to cosine of e to the x, and that gonna be u in the first step. Now du gonna be equal to minus sine of e to the x multiplied by e to the x dx. Now we only have e to the x sine of e to the x ex dx, so I'm gonna move the minus sign to the other side. So this is gonna be easier when I make the substitution. For the second step, I'm gonna arrange the terms in here. I bring the ex, which is the first term, next to the sine of ex. Note in here, cosine cubed e to the x can be written as cosine of ex all cubed. From step number 1, u is equal to cosine of e to the x, so that's gonna be equal to u cubed. What's left off from the integral, this is just minus du. Therefore, this integral gonna be equal to u cubed and then minus du. Now I'm gonna pull the minus sign out of the integral, and we are left with the integral of u cubed. We already know what's the antiderivative of that function. going to be equal to minus u to the 4 over 4 plus c. Now, step number 3 is to back substitute the function of u from step number 1, which is cosine of e to the x. And that's our entire derivative.